The infamous Thermite mixture consists of iron oxide and aluminum. And we're going to make iron oxide with some easy chemistry. Electrolysis is the process of using electricity to start a non-spontaneous reaction. In this case, we'll be turning iron into iron oxide using this method. It is important to use DC current. We're using an old computer power supply. More options are batteries, DC transformers and battery chargers. We start the experiment by adding some water to a container. To make the water conduct better, we add salt. Any amount of salt will do, but we found that the saturated solution is the fastest. The disadvantage of this is that there will be a lot of salt in the finished product, or you will have to spend quite a bit of time decanting the salt out. Stir it a little and wait for the salt to dissolve. Then you will need a cathode and an anode. They both have to be conductive. And the anode will turn into the iron hydroxide that will later decompose into iron oxide. For our anode we will be using an iron nail, but we will change it over time because it will dissolve, turning into the hydroxides. For the cathode, a piece of iron will do. You can use a pencil core or some copper, anything conductive really. Make sure the power supply wires are not touching the water, or else the wires will oxidize as well, and you want to use those more in the future. If you are using a power supply like we do, or if you want to use one, it will not start automatically. The PSU needs a signal from the motherboard to switch on. You can cheat our way around it by connecting the green wire with the black wire. A piece of iron will be fine. I recommend putting a switch on it because every time your wires will short out, the power supply will turn off. You will have to put the wires back in. A switch will be much more convenient. Turn on your power and lower your electrodes into the water. The anode needs to be the positive wire and the cathode negative. If you switch these two around, the other electrode will dissolve. You are now looking at a time lapse of the process. The green fog coming from the negative side is the iron hydroxide that we're after. It will later sink down to the bottom as a greenish blue sludge. There are a lot of chemical reactions taking place, but the most important one is the following. The iron reacts with the water to form iron hydroxide and the hydrogen gas. Under some circumstances, chlorine gas can be produced, which is toxic, and hydrogen is always produced, which is explosive. This is why you should always perform this process in a fume hood or outside. We moved the cell outside after the time lapse. As you can see, the layers of hydroxide and water are separated. This is something we have never seen before. There are so many variables that every setup will be a bit different, so don't worry if yours doesn't give the exact same results. Just remember that the purer the iron, the better, so that there are no oxides from other metals present. And for the speed of the electrolysis, amperage is what matters, not voltage. You will of course need some volts, but high voltage will only heat up the cell. We've tried some voltages and found that 5 volts works best for us. If you want to increase the amperage, move the electrodes closer together and add more salt to the solution to make it more conductive. Your cathode will probably develop a crust. This is just some iron oxide. Under this crust, the electrode is severely corroded. The water has already developed a reddish brown color. This is because some of the iron hydroxide has already decomposed into the red rust. Turn off the power and lift your electrodes out of the water and pour the contents into the decanting bottle. Make sure you get everything, especially the sludge. You should probably use a funnel for this. With the decanting bottle we will get the salt out of the solution, so we can boil it down without the salt crystallizing inside of our iron oxide. To make the decanting bottle, we're just going to light a candle and grab a small nail and hold it with a pair of tweezers. When the nail is hot enough, poke small holes in the bottle. You should end up with a series of holes going all the way to the top. To seal them up, Grab a chunk of candle wax and melt it above the candle. Once there's a molten drop of wax, quickly place it on top of the hole to seal it. Make sure the bottle is dry while doing this, otherwise it won't seal. After you have poured the solution into the bottle, let it settle to decide at which hole you will break the seal. In this time lapse, you can clearly see the sludge settling on the bottom of the bottle. After about 20 minutes, we will scratch the wax off the hole just above the settled sludge. The water containing the salt will pour out, and you must screw the cap open, otherwise it won't pour out. There is still some salt water left in the sludge, so you should seal it back up and repeat the process about 4 times to minimize the salt percentage. Sealing the bottle up while it still contains some sludge can be hard, but just lay the bottle on its side with the holes facing up and reseal it. Now there's almost no salt in the solution, so it's ready to be boiled down. Pour the content into a heat resistant bowl that you don't mind getting dirty. We could just leave it out to evaporate outside, but we are going to fire up the oven at 150 degrees Celsius and place the bowl in there for a few hours. Be careful while putting it in and don't spill like we did. After some time, get your bowl out of the oven. All of the water should have boiled off and a crust of iron oxide should remain. You can see a lot of salt in our batch, and that's because we only decanted it once. Crush it up with something like a fork. It should be a lot finer, but to really make it fine, you must first put everything in a glass jar. This can easily be done with a piece of paper. To make it fine, give it a good shake. There you have it. You have made a batch of homemade iron oxide ready to be used in Thermite.